Welcome back, students. Last time we discussed the energy of particles, and if you remember, alpha particle was bombarded on thorium, and different uranium isotopes were obtained with the different number of neutrons depending upon the energy of the alpha particle. So we also came across a conclusion that if we change the energy of alpha particle during bombardment it on the thorium nucleus target nuclei, so we will get different number of neutrons, and that energy what we discussed was actually the endothermic energy or energy required for the system in order to initiate nuclear reactions in it. So the amount of energy, kinetic energy required for a particular bombarded particle was very important for production of products and the number of neutrons in the given reaction or given process or given species. So next is production of nucleides. Now, from previous discussions, I hope you are able to what we can say, to balance the nuclear reactions because there are certain phenomena we have to take on board those phenomena and then to balance the equations. Now, this production of nuclei beyond uranium, the phenomena the production of nuclei will mean strictly that those elements, those metals which appears after uranium, and those elements which follow uranium, they are called trans-uranium elements. So the same phenomena radioactive synthetic chemistry has been exclusively studied for nucleides which are beyond uranium, and definitely this is the actinide series. Now in this series we have to discuss certain reactions. Let this is uranium-238 being bombarded by heavy hydrogen. So we have to balance the atomic number and atomic mass of these two species. So uranium-238 with atomic number 292 bombarded by a heavy hydrogen. So neptunium, which is heavier than uranium, can be produced along with a neutron. This neutron can have different energy, can be thermal or can be fast moving neutrons. So this process we have to utilize for certain other useful purposes. If the neutron has more kinetic energy, then we have to utilize the kinetic energy. We have to remove this kinetic energy from neutron and to use the neutron itself for other nuclear reactions. This uranium is then when bombarded by a relatively heavier particle, that is helium or alpha particle. So again, you have to check the atomic mass and atomic number of these two species. So plutonium is produced, and plutonium along with three neutrons, and these neutrons again we have to use for other useful constructive purposes or constructive uses. Plutonium is when bombarded with helium, so americium is produced along with a proton and two neutrons. Then plutonium, again bombarded by helium, can also be cubium when there is no proton produced in the process, and definitely now since the reactions are identical, so we have to locate where the difference in these two reactions we expect. So we expect the difference in these two reactions here, that the energy of the alpha particle being bombarded and the starting material will be different. So in this case, energy will be of one type, and in this case, the kinetic energy or the acceleration energy of helium or alpha particle will be different. Therefore, we will observe different products. For example, in this case americium, and in this case cubium. Here we will get only one neutron, and in this case we will get two neutrons and one proton. And this nuclei is even heavier than this one, where the two difference in atomic the difference of two in atomic numbers of these two species can be observed. This is starting material and this is now the daughter cell, the daughter nuclei, sorry, not cell. Curium is when bombarded by helium particles, so by helium is produced along with one proton and two neutrons. Now, in other series of reaction, when uranium is bombarded by a heavier particle which is far heavier than helium or heavy hydrogen, that is carbon 612. So californium is obtained along with four neutrons, and uranium bombarded by nitrogen can be used for production or synthesis of einsteinium along with five neutrons. Uranium bombarded by oxygen can be used for the production of fermium along with five neutrons. Einsteinium bombarded by helium or alpha particle can be used for mendelevium, and curium bombarded by carbon 13 can be used for the synthesis of nobelium along with five neutrons. And lastly, the californium bombarded by boron 510 can be used for the last member of the series, that is valencium, along with five neutrons. Now, in these both series of reactions, we have to observe certain common things. This series indicates that the particles, the target being bombarded by lighter particles, and these lighter particles are mostly alpha particles. So depending upon the energy of alpha particle, products can be predicted. And here the only the particle which is different is heavy hydrogen, which is relatively lighter than these two. So these are one type of reactions. In this case, what we are doing, we are using heavier particles: carbon 12, nitrogen 14, oxygen 16, helium, carbon 13, and boron 10. Now, in this case, one other thing we have uh, to, to mention or to observe, that helium possesses atomic mass 4, carbon is 12, oxygen is 16. If we consider the nuclei of these particles, bombarded particles, so helium nucleus will contain 2 protons and 2 neutrons. Carbon contains 6 protons and 6 neutrons, and similarly oxygen contains 8 neutrons and 8 protons. It means whenever we want to bombard these particles on any target nucleus, or whenever these particles are absorbed by any target particles, radioactive particle, what happens, equal number of neutrons and protons are added to their nuclei. So the addition of equal number of protons and neutrons to the nuclei of the target nucleus means we have nothing to do with the neutron to proton ratio, because neutron to proton ratio does not alter during these during these nuclear reactions. And whenever there is no change in neutron to proton ratio in the parent nuclei and daughter nuclei, so this parameter, this measure cannot be taken on board for estimation or for prediction of further nuclear reactivity of these species. So we have now to discuss other factors which determine the stability or instability of these nuclei being bombarded by these particles. Now this is, for example, neutrons are evaporated in preference to protons, leaving the target nucleus neutron deficient. Now what we have to discuss or we will observe that